anything. There was a widespread belief in the power of science. The heroes of 19th century society were the scientists, the inventors, the travelers to distant regions. This is the story of a man who exemplified that age, a man of his time who transcended it. In the summer of 1850, a woman older than her years arrived at the University of St. Petersburg. She was in mourning, and she was accompanying a thin 16-year-old boy. On the stairs, they said goodbye. She left, grieving that her husband had not lived to see this day, when the future of their youngest, their 17th child, was finally secured. She could hardly have guessed that one day this very street would be named after her son. Dmitri Mendeleev. Within a month, Mendeleev's mother had died, leaving him all alone in the big city, where he knew no one. He had no money and no friends. What he did have was a very inquisitive and sharp mind. He applied himself and quickly stood out from among his fellow students. He was a hard worker. I owe everything to this school, my whole intellectual development. After my first year, I began to spit blood, and this situation continued throughout my stay here. I couldn't have lasted at another school or fulfilled my hunger for knowledge, for here everything was close together. The lecture halls, the library, the laboratory. I could study full-time. The academic program covered a range of subjects. The natural sciences were stressed. Zoology and botany, physics and mineralogy, mathematics and natural history. The doctors suspected that Mendeleev had consumption, and he spent half a year in the hospital. Alone, far from his native town of Tobolsk in Siberia, where his father had been a teacher at the high school and his mother managed a small glass factory. Mendeleev said that it was at the glass factory that he learned his first lessons about people, nature, and work. He was interested in everything. Morse's telegraph had just made its appearance, also the barometer, the rotary press, which replaced the old flatbed. Joule had figured out the mechanical equivalent of heat. Every day there was word of new inventions and discoveries. Mendeleev worked and worked as if time did not exist, as if his physical body were as strong and seemingly limitless as his mind. And indeed the world of science opening before him appeared to be endless. He loved all science, but most of all, chemistry. It was a rather new idea to distinguish clearly between two kinds of substances, elements and compounds. In all the sciences, and particularly in chemistry, There were heated debates between opposing points of view. The outcome of these debates would depend not on intelligence or intuition, but on accurate experiments and precise measurement. Mendeleev was already known for his ability to carry out very accurate measurements. He was fascinated by the apparently infinite possibility of chemical transformations, given only the few dozen chemical elements that exist in the world. The development of analytical chemistry greatly increased the knowledge of chemical and physical properties of various substances. Principles of classification were needed. Mendeleev wrote his thesis for graduation on isomorphism. It dealt with the chemical processes related to the formation of crystals. The thesis earned him a gold medal. His prospects, too, were golden, but his health got in the way. The doctors said he wouldn't last another year in the climate of St. Petersburg. He would have to move south. So he took a job in the Crimea instead. Then it turned out that the doctors had made a mistake. He didn't have consumption after all. So he moved to Odessa, where it was easier to continue his scientific work. In May of 1856, he returned to St. Petersburg to take the examinations for an advanced degree. Of course, he passed and presented a paper on specific volumes. He was a strong believer in making science comprehensible to everyone. He thought that scientific research should be put to utilitarian ends, to improve the status of mankind. In 1859, the university sent Mendeleev abroad to continue his research. He set up shop in Heidelberg, rented a room, and proceeded to build himself a lab with equipment built to his own specifications. For quite a while, he worked without achieving any recognizable results, at least not the ones Mendeleev was looking for. He was specifically trying to determine something, which became clear at the First International Congress of Chemistry in Karlsruhe. Europe's top scientists, Zinin, Wurtz, Dumas, Cannizzara, were together attempting to establish agreement on some basic chemical concepts: atoms, molecules, atomic weights. Mendeleev immediately noticed that the changes suggested for atomic weights seemed to form a logical pattern. He decided to investigate the subject in greater depth. When he returned to St. Petersburg, Mendeleev sat down and in practically no time at all tossed off a textbook on organic chemistry, a brilliant book which was immediately well received. Mendeleev's reputation was growing beyond the confines of the chemistry lab and the university. He was about to be drawn into the burgeoning field of technology. Steamship and railway companies were sprouting seemingly everywhere, using the latest technology without being trained in it. They needed an expert. Mendeleev was approached. He examined the possibilities of extracting oil in the Caucasus, of manufacturing glass and making cheese, farming and wine production. He was getting ready to settle down and acquire the customary trappings of academic life. A wife, for instance. He married a woman he had known in his hometown of Tobolsk, bought some land, built a traditional-style house — he was an innovator in chemistry, not architecture — and began to apply his scientific mind to improving crop yields. In time, his children began to help him. Volodya and Olya. Professor Dmitri Mendeleev was the realization of everything that the sickly young boy from Siberia could have dreamed of. The university even gave him an apartment, and he lived in the same building in which he had spent his student years. In the lab, he sought to produce proofs of the hypotheses which he had worked out in his mind on paper. Mendeleev was readying for publication a series of lectures on the essentials of chemistry. The accumulation of facts had to be organized in a logical and consistent manner. Understanding science requires not only information, but organization in order to understand, to visualize an entire concept. When not all of the necessary information is available yet, one must search for the beauty and harmony that characterize the truth. In the 19th century, a scientist could admit searching for beauty and truth. Mendeleev began to work harder than ever, burning the midnight oil. He sensed he was nearing the moment when all would become clear. Everyone knows that the alkaline metals, sodium, lithium, and potassium, are similar to one another and dissimilar to the halogens, chlorine, bromine, and iodine. There must be some law that defines the relationship of these elements to one another. For 3 days and 3 nights, he worked without interruption to check and recalculate his hypothesis that families of elements are dissimilar to one another, but that within a family, the relationships between all of the elements are identical. As the atomic weights increase, there is a corresponding periodic change of properties. On February the 17th, 1869, he drew up a table which laid out in black and white how the elements, arranged according to the magnitude of atomic weights, show a periodic change of properties. The table would come to be known as the periodic table of elements. All of the chemical elements known in 1869 were set down in numerical sequence by their atomic weights. Mendeleev was quite certain that he had discovered a fundamental law of nature. He was also sure that there were many more elements that had not yet been discovered. He provided a detailed account of 3 elements that had not yet been discovered. His fellow chemists were not prepared to accept this at face value, for they thought the periodic table merely an organizational formula, a theoretical tool. The world of science was not ready to accept the significance of Mendeleev's discovery. It took just 6 years for Mendeleev to be proved right. In 1875, a young French chemist announced to the French Academy of Sciences that he had found certain distinctive signs which led him to conclude he had discovered a new element. Mendeleev immediately wrote to the Academy to assert that the young Frenchman had discovered one of the elements that he, Mendeleev, had predicted in his table, which he called Eka aluminum. Mendeleev even pointed out a mistake the Frenchman had made in his calculations. The disappointed young chemist repeated his experimental work. To his chagrin, Mendeleev was right. Mendeleev had indeed predicted the properties, even the melting point of the new element, called gallium, after Gaul, France. "My predictions have been proven right," said the jubilant Mendeleev. "My place in science is assured." It was a triumph for the periodic table. Soon 2 more elements which he had predicted were discovered, scandium and germanium. There were to be many others. The 101st was named in his honor, Mendeleevium. But that was a century later. In his own lifetime, Mendeleev was a prophet showered with honors. His books were bestsellers. Students flocked to hear his lectures. Scientific associations and academies around the world elected him to membership, and he collected a shelf full of medals and honorary doctorates. But he was not yet ready to rest on his laurels. His interests ranged across a broad field. He devoted himself to the study of gases. He published a book about the oil industry, which was useful both to scientists and to those working in the production of oil. To gather data, he visited the U.S., the oil fields in Pennsylvania. In the lab and in the lecture hall, he was successful and happy. At home, it was another story. In the spring of 1877, Mendeleev's sister came to live in his vacant Moscow apartment, together with her daughter and her daughter's friend, Anya Popova. Like the discovery of new elements, this plot was utterly predictable. Mendeleev fell in love with the 17-year-old Anya, a painter. The prognosis was not good for this love affair. His wife would not give him a divorce. Anya was afraid to cross her parents. Everyone was down on Mendeleev. He worried about the effect on his children. But despite everything, love prevailed. In 1882, Mendeleev and Anya were married. He was 48, she was 22. Now Mendeleev's lifestyle changed. He made new friends. His home became a kind of salon. Artists came to visit. Wednesdays there were tea parties. The guests signed their names on a large tablecloth, and Anya embroidered the autographs. A new life had begun for Dmitri Mendeleev. But just as he had before, Mendeleev spent most of his time working. His energy appeared undiminished, and his interests kept widening. He was searching for the idea that would connect everything, the unifying principle. He devoted many years to the development of his theory on the nature of solutions. The resulting book was filled with tables reflecting the most careful measurements. He was very proud of this work, which provided a new interpretation of the structure of an entire class of chemical compounds. He dedicated the book to his mother. Your legacy to me was the behest to work hard to do something, not just talk. To persist in searching below the surface to the essence of a thing. In other words, to seek for scientific truth. Throughout his life, Mendeleev tried to follow his mother's precepts. He had the courage to work and to take risks, physical risks like going up in a balloon in order to perform experiments. From his balloon, he observed a solar eclipse and took pleasure in the beauty of the Earth seen from above. When the university students protested some university restriction, Mendeleev himself presented their petition to the administration. He was aware of the possible repercussions, but he had the courage of his convictions. The administration refused to accept the students' petition, whereupon Mendeleev immediately resigned his position and left the university, an institution which had nurtured him and to which he had in turn devoted many years of his life. He took leave of his students and of his colleagues, many of Russia's leading men of science, and he left his lab. He would have to start everything from scratch. Nevertheless, he proceeded full steam ahead. He was approaching his 60th birthday as he embarked on all sorts of new ventures. He made the Russian oil industry more effective. He disproved the rumors that the Baku oil fields were exhausted and called for greater efforts to develop petroleum byproducts. He tried to develop smokeless gunpowder. And wrote a book about import tariff policies. "You think I'm a chemist?" he joked. "I'm actually a political economist." In 1892, he embarked on yet another career. He became chief curator of the Bureau of Weights and Measures. The Bureau had 3 employees and was, when Mendeleev arrived, in a state of chaos. Mendeleev took hold and before long managed to turn it into a center of science. Now Mendeleev was truly in his element. Since his early school years, he had always enjoyed using sensitive instruments and taking precise measurements. Mendeleev developed a theory of weights and weighing. He checked all the units of measurement used in Russia, including measures for granular bodies. He invented a new one-arm scale and improved the scales for weighing in a vacuum. Mendeleev insisted that there be one single system of weights and measures for all of Russia. A colossal job, but critical for the modernization of Russian industry. The system created by Mendeleev is the one still used in the Soviet Union today. But as always, Mendeleev was not satisfied with only one field of science at a time. During the day, he worked at weights and measurements. At night, he wrote books, setting down his thoughts in many scientific disciplines. He was racing the clock. There was so much he still wanted to do. He was going to sail the Arctic Ocean in an icebreaker he had himself designed. He wrote a book on philosophy, which sold extremely well. He seemed to have arrived at some new unifying concept that grasped the connection between seemingly disparate relationships, as did the periodic table. But time had run out. Mendeleev had accomplished more than a lifetime's work when he died in 1907. He left this letter to his children. From their father, to be opened only after my death, and in any event not before 1888. Signed, D. Mendeleev. If there are misunderstandings, he wrote, that's not so terrible. You should strive not for intellectual brilliance or surface success, but for intellectual honesty and serious endeavor. Let these be your guides. Since Mendeleev's time, the atomic weights of some elements have been redetermined. Rutherford's experiments on the scattering of alpha particles led to the determination of the nuclear electrical charge, the ratio of which to the charge of the electron turned out to be roughly half the atomic weight. By taking this quantity, the atomic weight, and correlating it with the ordinal number of the elements in the periodic table, the problems of order appear to have been solved at last.